Okay, this is a question paper, KZN, November 2023, grade 11. So, question 5, trigonometry. For this type of question for trigonometry, it will need certain basics, but I'll explain about it later. We'll continue with this one. 5.1 and 2, we continue. And the 5.3.1, simplify. Then the next one, 5.3.2 until 5.4.2, it needs the basics. Okay, I'll explain about these basics now. This one. Before we start answering this question, let me first explain about this basics, because it will need these basics here. Now, here are the basics that we need to know. Grade 11 learner. Now, this is a Cartesian plane. So, in the Cartesian plane, you can see that I include, let's look at on the first quadrant. Now, on the first quadrant, we have a 90 minus theta, or here you can put any angle here. It can be 90 minus x or 90 minus y. You can put any angle here. And then 360 plus theta. So it means that now 360 plus theta, 90 minus theta are in the first quadrant. Now, in the first quadrant, we have sine, cos, and tan are positive in the first quadrant. That's why we put A. All are positive in the first quadrant. Now we go to the second quadrant. In the second quadrant, we have 90 plus theta and 180 minus theta. So 180 minus theta, 90 plus theta belong to the second quadrant, are in the second quadrant. So now in the second quadrant, we found that tan and cos are negative. Tan and cos are negative in the second quadrant, and then sine are positive. That's why we put S. Now, let's move on to the third quadrant. Now, in the third quadrant, we have 180 plus theta, and then 270 minus theta. Now, 180 plus theta, 270 minus theta are in the third quadrant. And then now, in the third quadrant, we have tan is positive, sine is negative, and cos is negative. It means that in the third quadrant, sine, cos are negative, and tan are positive. That's why we represent by T. Now we move on to the fourth quadrant. Now in the fourth quadrant, we have 360 minus theta, 270 plus theta. Now in the fourth quadrant, we have cos is positive, and then sine is negative, and tan is negative in the fourth quadrant. So in the fourth quadrant, we have 360 minus theta, 270 plus theta belong to the fourth quadrant. And then we'll plan by C. First quadrant, second, third, and fourth. A stands for all, S stands for student, T stands for drink, and then C stands for coffee. All students drink coffee. Okay, so that you don't forget. You need to master this table in order to answer some of the questions based on trigonometry. Now let's move on for this one. This one are called confunction. Now confunction, we are talking about this type of 90 minus theta, 90 plus theta, 270 minus theta, 270 plus theta are called confunctions. And then we say change. You see how we say change for these ones. But you need to know that confunction consists of 90 minus theta, 90 plus theta, 360 minus theta, 360 plus theta are called confunction and change. I'll explain later how they change to. Okay, and then when we move on, now we have what we call a reduction formula. A reduction formula, we are talking about 180 minus theta, 180 plus theta, 360 minus theta, 360 plus theta, we call unchanged. You must know that 180 minus theta, 180 plus theta, 360 minus theta, 360 plus theta are called unchanged. Okay. Now let's move on. Now we have something what we called. Okay, let me start see whether I cannot explain about this change or unchanged. I'm not sure whether I have this. There we go. Example about this when I talk about change and change. Like for instance, now I say 90 minus it's based on cofunction. Now when we have a ratio here, say cos 90 minus theta, then it becomes sin theta. How it becomes sin theta? Because we say 90 minus, we say in which quadrant? First quadrant. You can see that 90 minus is in the first quadrant. Then the next we say cos, this ratio here, cos is positive or negative on the first quadrant. Cos is positive on the first quadrant. Then say change or unchanged. You look at this thing, 90 minus. Then say okay, 90 minus there. Do what? It changed. It changed to what? When cos change, it will change to sine. That is why we have cos 90 minus theta. It will change to sine if it change. Now, another part now. Let's say we have sine. Okay, 90 minus theta. You say 90 minus in which quadrant? 90 minus is in the first quadrant. Then check the ratio. The ratio is sine. Sine, is it positive or negative on the first quadrant? Sine is positive. Then come sine change. Yes, it's changed. Why? Because there's 90 minus. Because 90 minus, according to cofunction, it changed. So if sine change, it will change to cos. If cos change, it change to sine. Okay, let's look at here. Cos 270 minus theta. 270 minus theta. 270 minus in which quadrant? You check in which quadrant. You use the table. Cos, okay, 270 minus, oh, it's in the third quadrant. In the third quadrant, then the next step, we check in front of 270 minus. Now there's a ratio cos. Now cos is positive or negative on the third quadrant. Oh, cos is negative on the third quadrant. Then the last part say change or unchanged. It changed because 270 is fall under cofunction. 270 minus, it changed. Now it changed to what cos? Cos, it will change to sine. That's why the negative comes from to say 270 minus is in the third quadrant. Cos is positive or negative? In negative, that's why you write the negative. And then 270 minus, is it change or unchanged? Change, because 270 is a cofunction, it changed to sine. Cos changed to sine, and etc. The same thing for reduction formula. So this one is unchanged. Like for instance, let's say 180 plus in which quadrant? We know that 180 plus is in the third quadrant. Okay, now cos in the third quadrant, is it positive or negative? You check. Cos is negative in the third quadrant. Okay, you write a negative. And then change or unchanged? Unchanged, because 180 plus is a reduction formula. Reduction formula 180. This reduction formula is unchanged. So cos won't change, will remain as cos. Okay, I think it is clear. It is clear. It is clear. Now let's come to what we call SOHCAHTOA. SOHCAHTOA. F stands for sine, O opposite, H hypotenuse, C stands for cos, A stands for adjacent, H stands for hypotenuse, T stands for tan, O stands for opposite, A stands for adjacent. Now, here is a right angle triangle. How do you see that it's a right angle triangle? We see by a 90 here. There is a 90 here. Now, you apply SOHCAHTOA or theorem Pythagoras on a right angle triangle. You cannot apply theorem Pythagoras to any triangle except a right angle triangle. Even SOHCAHTOA, you apply what that's a right angle triangle. So now let's see. Theorem of Pythagoras. Now the formula for theorem of Pythagoras, r squared is equal to x squared plus y squared. So the side that is opposite to 90 we call hypotenuse. You start with it, and it's equal to the sum of other sides. It's equal to the square of the sum of other sides. So this is the formula of theorem Pythagoras. If you represent with letters, you have AC squared. AC squared is equals to BC squared. BC squared plus AB squared. AB squared. We call this formula a theorem of Pythagoras. Now let's come to trig ratios now. It depends by the position of the angle, because now for SOHCAHTOA we say sine always doesn't change. It's opposite over hypotenuse, cos is adjacent over hypotenuse, tan is opposite over adjacent. That doesn't change. So the opposite in the triangle or the adjacent or it depends by the position of the angle. So hypotenuse does not change. Any side that is opposite to 90 always is hypotenuse. But this side and this one can change, depends by the position of the angle. Now let's see. If I'm going to use theta as a standard position for this angle, now let me see. You see, when you say sine, we know that it's opposite over hypotenuse. So opposite over hypotenuse, I say is y over r. I'm using theta. Now first, I have to identify where is my hypotenuse. My hypotenuse is this side. It's always opposite to 90. Then I check the angle that I'm using. I'm using this angle. So this angle is opposite to this side. So if this is hypotenuse, this is opposite, then obvious the last one will be adjacent. So now, when I apply SOHCAHTOA to say sine is opposite over hypotenuse. That's why we have y over r. The next one is cos theta. Cos theta, we know that is adjacent over hypotenuse. Let's see here. Adjacent, remember, this side is always hypotenuse. This side, which is opposite to, or this angle is facing this side. The side that the angle is facing is opposite. Obviously, this one will be adjacent. So according to SOHCAHTOA, cos is adjacent over hypotenuse. It will be adjacent over hypotenuse. So it's x over r. Tan is opposite over adjacent. Opposite over adjacent. So it's y over x. Let's come now. The position of the angle now, we are using alpha. When you use alpha, let's see. Remember for this side, we're using theta. It was say opposite over hypotenuse, y over r. Look at now. We are using this angle, alpha. The opposite will be which one? The opposite will be this side. The side that the angle is facing is the opposite. This one, hypotenuse, does not change. Always it's hypotenuse because this line is opposite to 90. Then it means the last part now will be our adjacent. So now let's see. Sin alpha opposite over hypotenuse. So over x over r. Cos alpha adjacent over hypotenuse. And then tan alpha opposite over adjacent. This is how you apply the trig ratios. Let's see. The next part is called negative angles. So negative angles meaning that sin theta into negative sin into negative theta, it becomes negative sine theta. Remember, here can be any angle, can be x, can be y, can be alpha. Cos into negative theta, it becomes positive cos theta, does not have a negative. And then tan into negative theta, it becomes negative tan theta. We call this negative angles. Okay, negative angles. Let's look at this part. Okay, I think this ones I will explain when you do more questions and stuff like that. Let's look at this one. This one is called square identities. You know that cos squared theta plus sin squared theta is equals to 1. Those are the formulas that are given. They are called square identities. You can change from this standard formula. You can do that like this. It means that cos squared theta is the same as 1 minus cos squared theta. Sin squared theta is equals to 1 minus cos squared theta. Cos squared theta is equals to 1 minus sin squared theta. Minus cos squared theta is the same as sin squared theta minus 1. Minus sin squared theta is the same as cos squared. Sorry, here is a mistake. I think I will need a pen to rectify this mistake here. Here it's supposed to be, let me check. It's supposed to be theta here. Theta, I don't write it well. Theta. Okay, minus sin squared theta is equal to cos squared theta minus 1. We call square identities. This is a cosine graph, but I'll explain when we answer questions. How to use graphs to answer certain questions. Even for this one, because you know that if you start from here, start from 0 on 80 to 70 revolution, it becomes here is 360. If you continue again, you add from 360 to other values and become here, which is another 360 as well. 360 by 360, I think it gives us almost 720 somewhere there. Okay, and then we'll be here. Then we'll explain when you answer some of the questions. So let me see whether I can explain everything based on the question that will be following. Yeah, it seems like I've explained everything. Yeah, I'll answer the question, come back on these notes and referring this note to check we answer them properly. So now let me take one of this one and then show you how it's important to know these basic things or those notes that I've done here. Very, very important. Okay, now, for instance, let's look at this question here. Look at this question here. Question 5. Question 5. If you can see question 5, it says that 5.1, if sine 33 is equals to m, determine the following in terms of m without the use of a calculator. So meaning that now here we are going to solve this problem without the use of a calculator, and then your answer must be in terms of m, meaning that you'll have an answer and then the answer must have an m inside. That's the meaning of it. Now, this type of question, to answer it, if sine 33 is equal to m, there's no restriction where they say that maybe m is an element of 180, blah blah. There's another question for this one. As long as there's no restriction for that one, it's like this. How do you answer this type of question? I'm not sure whether I should draw this line here. A triangle actually. Let me draw a triangle. This is a triangle. I draw the triangle here. You draw a triangle. If you see this type of question, you draw a triangle. Actually, it will be a right angle triangle. draw a right angle triangle where there's 90, right angle triangle. After that, you see there's an angle here, 73 degrees, you put it here. Let's see, you just put it here, 33 degrees. Now, you know that the sum of a triangle are added to 180 degrees. Then if here is 90, then here is 33 degrees. Then what about here? The angle will be. So in the quickest way, you can say that 180 minus 90 minus 33, you get that angle. Or you can say that this angle is 90, and then these two angles must form 90. This one and this one must form 90 as well. So you can say 90 minus 33. So there's many ways to solve and get this angle here, or 57. So 57 plus 33, I hope it's 90. Now, when you see this type of question, draw a triangle, a right angle, or a right angle triangle, fill up all the angle inside, then you must fill up all the side as well. Now, look at the ratio here, it's sine. If it's sine, then remember SOHCAHTOA. SOHCAHTOA. What is SOHCAHTOA? SOHCAHTOA is a sine is, if you remember this one, SOHCAHTOA is a sine is opposite over hypotenuse. Now, to identify your hypotenuse in a triangle, be careful. I say that to be easier, you say 90, the side that is opposite to 90, this side, always is your hypotenuse. You have to start with it, it's your hypotenuse. The side that is opposite to 90 is your hypotenuse. And then now, we are going to use this angle here, as it's been given in our question. Now, this 33, this angle is opposite to this side. So, mean that this side is opposite this angle. So, this side is opposite. This one is hypotenuse. Then, therefore, this last side, it will be adjacent. What if you're using this angle here, you check the angle that is the side that is facing is your opposite, and then hypotenuse always is opposite to 90. Then it means this last side here, it will be your adjacent. Okay, now here we have you can rewrite this one, say sine 33 degrees is equals to m. They've given us here in the question. No statement that. Then now, what we're gonna do, you're going to say, look at here. It just says sine 33 is equal to m, and then below m there's nothing here. Then what you're gonna do, say, okay, there's nothing there. It means that there is 1. You cannot see it is there. There is 1. Just say m over 1. Then sine, according to SOHCAHTOA, is opposite over hypotenuse. So it means that is opposite over hypotenuse. Opposite over hypotenuse. It won't change. According to SOHCAHTOA, opposite over hypotenuse, meaning that opposite here is m, hypotenuse will be 1. Then you go to the triangle. I said that the side that is opposite to 90 is our hypotenuse. And then we have identified that your hypotenuse in this situation is 1. Then you can put 1 here. 1. Okay. Let me do like this. Okay. 1. I don't know. Okay. 1. Now. And then now opposite by using this angle. Now in this section, our opposite is M. Then put M here. There we go. Now you have to fill up this side. To fill up this side, okay, you can put, say that hypotenuse here. 1 is for R, and then this vertical line. Let me check. This vertical line, say that is for Y, and then this horizontal line here, you can say that is for X. Then now you can apply theorem Pythagoras to answer this side. So you can say theorem Pythagoras will say that R squared is equals to X squared plus Y squared. Now R we have is 1 squared, and then X is the one that we are looking for, X squared, and then Y is M. Okay, then now what you're gonna do, let me look at the blank paper. Okay, there we go. Then it will be 1 squared is 1 is equals to X squared plus M squared. Then now we are solving for X. So you write 1, take M is positive, my jumper equals sign becomes negative. Negative M squared is equals to X squared. Then the next part, we are looking for X, not X squared. So in order to remove that square on top of X, what we're gonna do, we need to square both sides. Put the square root both sides. Square root both sides. Then, okay, let's continue. We're going to have 1 minus M squared is equals to. Now the square root will go with 2 here, then we're left with only X. So we can go to say, therefore, X is equals to root 1 minus M squared. Then it means that here in this triangle, go and fill up this triangle, because all the answers will come from this triangle. All the following answers will come in this triangle. Come from this triangle actually. So there we go. Okay, it will be like this now. Okay. Yeah, now we have filled up the triangle. Then we can start answering our question. Look at the question. The question is 5.1.1. They say that you need to determine the following in terms of M without using of a calculator. Now here we have tan 33 degrees. Now to answer this one, check tan 33 degrees. Let's look at the triangle. We're going to use this triangle. Now tan, you apply isokatua, remember? Sokatua, tan is opposite over adjacent. Then in your triangle, first we need to identify the side. Now, this side we say is always hypotenuse, is opposite to 90. Now 33 is here in this position. it means that now the side that is opposite to 33 is your opposite, and then that last line there, it will be your adjacent. So what you're gonna do, you say, okay, tan is opposite over adjacent. Opposite over adjacent. Now, opposite over adjacent. Then let's check. What is opposite? Opposite m over adjacent root 1 minus m squared. So it means that here opposite would be m over root 1 minus m squared. Then you're done. That's your answer. That's your answer. Okay. To continue with other questions, let me take a break. Then we'll continue with this one, 5.1.2, and then the question is still continuing. That question is based on question number 5, so it's continuing. So let me take a short break, then we'll come back and continue with those questions. Thank you.